tells us the area under the curve, and if you integrate from a to b, it's f of b minus f. The second fundamental theorem of integral calculus states the following. Notice this goes from 2 to x, so x is a variable, of f of t dt. You integrate it and you get f of t from 2 to x, which is going to be f of x minus f of 2. And you're going, well, that's no different. Now the shaded area is here, and what I want you to recall, f is the antiderivative of f. So what happens is if I take the derivative of an antiderivative, I'm going to get f of f. So here's my f, and I take the integral, that gives me the original function, and if I take the derivative of this, I'm going to get back to f. So what I want to write down is f of x equals the integral f of t dt. Oop, this is an x. All right, so here we have this funky curve, and it goes from 2 to 3, and they're telling us the area under the curve is 4. Then we go from 2 to 4, and the area under this curve is 9. And then we go from 2 to x, and they happen to tell us the area under the curve is 10.3. Okay? Yeah, that's what I meant. Okay? So now, here we have the area under the curve. We're going from 3 to x. We don't know what x is. The area under this curve is the integral of this, and it happens to equal f of x. And you're going, okay, right?
Right.
Now we're going to take, and remember integrals are just taking these little rectangles, adding them up. So let's say we go from 3 to 7. It's going to be f of 7. So let me say, this really shows that derivatives and integrals are opposites. Now what this theorem is going to tell you is that it guarantees that every function that is continuous has an antiderivative. So let me write this down. Did I spell that right? Guarantees that every function that is continuous does have an antiderivative. Okay? So here's the second fundamental theorem of calculus. You're going to really freak them out, aren't you? If f is a function and it is continuous on some open interval, and c is a number in that interval, then f has an antiderivative big F on this interval, which can be described like this. Notice it's a constant to the x. Well, most of the time you've had a to b, now it's to any x. Since f is an antiderivative of little f, then the derivative of f, big F, has to equal little f. Wouldn't it have been nice if they did different letters? So here's the key. This is what you're going to see a lot of, is this formula. The derivative of big F is the derivative of the integral, which is little f. Remember, guys, if you have f of x minus f of c, what's the derivative of f of c? C is a constant. What's the derivative of a constant?
0.
0.
That's not an excuse.
That's why you see just f of x here, because the derivative of a constant goes away. Yep. The derivative of t cubed over t over 3.
I mean, I already know what everything that happens.
Going from what?
know what that number is?
Yes.
9.
9? It's a 9.
So going from 9 to x. So what's the derivative with respect to x of x cubed over 3 minus 9 cubed over 3? No, what's the derivative of x cubed?
Why were 3? What is the equal part? Wait, isn't that the same thing we just had?
What you're finding out is you don't need to do this step once you realize that it's just going to be whatever this top limit is.
So
But I
every
needed
time
to
it's
show it
equal,
to you.
T squared, so
Do you see how this is taking the derivative of an integral? So I took the integral, then I put in my limits, and then I took the derivative of this, which is exactly what this is, but it's x squared.
So if we thought we could just write x squared.
Correct.
That's cool.
Pardon me, but what's different about this one?
It's got x at the bottom.
X at the bottom. So what we're going to do is say the negative of the derivative, oh, I'll put it out here. Derivative with respect to x of 4 to x sine t t.
Is that a negative sign?
This is a negative.
Why?
Because if we switch these limits, what do you do with the integral? Put a negative in front. All right. So, Josh, what would my answer be?
Your answer would be
Sin x.
How about negative
Negative.
sine x over x? All right. Is this in the right format?
I gotta write that.
It's the next
Say
way.
don't
Yeah,
edit
yeah.
it.
So what's my answer?
Special.
E to the negative x squared.
Very good.
Wait, I don't know what we're doing. Blair J. It's just
Notice the derivative.
So I'll just ask the question again.
All right. So, what's the derivative of natural log of x?
1 over x.
What's the integral of 1 over x?
ln x plus c.
If I take this one,
1 over x.
if I do this one.
Negative 1 over x.
All right, show you got a new definition of the derivative. We're going to get the same answer for this one. So let's take derivative with respect to x of ln x. That's the derivative with respect to x from 1 to x of dt over t. And that's 1 over x.
Okay.
That's our new definition. Y equals log base e of x. Can I rewrite that?
Yeah.
Yep. What do you want to do? ln x over, what's ln e?
1.
So I end up with ln x.
It's so loud.
It equals ln x.
Yep. What's the derivative with respect to x of this one here? I know they're back.
Dang it.
Dang it.
What's 1?
They're going to use that as a video.
Notice
Hope
you
they
get
do.
the same thing. All done.
Praise the Lord.
All done.
TL.
Wait, I
Now you can work on homework.